Assalamualaikum warahmatullahi wabarakatuh. This is video for chapter 5, Morphology. So we did cover on chapter 4, image color processing or image segmentation, color segmentation. And now we move to morphology. This is one of the method in image processing. For object detection, we can use morphology. After we perform color processing, also we can use morphology. So this is chapter 5. Understand the basic theoretical of morphology. Apply morphology analysis for feature extraction. So morphology is about the mathematical, and it is implemented in image processing from the mathematical theory, bring it to image processing. So we call it morphological image. Stands as a relatively separate part of image analysis based on the algebra of non-linear operator operating on object shape, supersede the linear convolution, yield fast algorithm. So this is an example of binary morphological operation. You have one image here, and this is the image. And when we perform morphological operation, we can get this kind of output. Okay, by fill up all the whole or white component inside the object. So this is a basic operation. This is all based on mathematics. A, B, A union B, A subset B. So we can apply or implement this mathematical operation into image analysis or image processing. Okay, so this is application of morphology, 2D or 3D. 2D means that two-dimensional grayscale, or we can also perform a binary morphology in 3D or RGB image. So its application is for shape simplification, shape enhancing, skeletonizing, thinning and thickening. For the grayscale morphology, so this is only two applications for grayscale morphology: image segmentation and noise filtering. If we have image in binary, binary means that 0 and 1. Grayscale 0, 2, 255. 255. So if we perform morphology to the binary, so its application is for shape simplification, shape enhancing, skeletonizing, thinning and thickening. So there are a few applications of morphology in binary format of image. But for the grayscale, it is only two applications, which image segmentation and noise filtering. So this is the difference between grayscale morphology and binary morphology. So there are a few operation of morphology, but for this class we just go for this dilation, erosion, closing and opening. So only these four. The rest you can get other morphological operation by yourself. No? So but for this class we only cover on this dilation, erosion, closing and opening. So before we perform morphology, we need to have a structuring elements. We call it structuring elements. Structuring element. It's like when we perform filter, when we perform filter operation, we have to have mask. So our mask is used when we perform filter, right? Mask means that the size of type of filter. So we need to have that mask. So it same goes to the morphology. We have to have structuring element. We need to have structuring element for morphological operation. So a structuring element is a shape mask used in the basic morphological operation. Can be any shape and size that is digitally representable, and it has an origin. So this is all types of structuring element. This is all types of structuring element. We have box, hexagon, disc, or any shape. So this is a structuring element which need to be used to perform morphological operation. We will see the example just later on. Okay. So we go first, morphological operation or dilation. So the dilation operator on sets A and B are defined by, so this is the mathematical denotation of dilation. A, B, A plus B, A exclusive or B, something like that. This is all the notation to represent the morphological operation dilation. But to make sometimes it's difficult to understand the mathematical operation here, Of course we can derive and we can explain from this equation, but it's easy if we just go straight to the image, how the operation of dilation. Okay, A is normally the image, while B is the structuring element. B is the structuring element. A is the image. B is the structuring element. So when we perform B, dilation B to the image A. So that's the function of structuring element. Dilation. So we have this A, our image. Okay, pixel value, pixel value, pixel value, pixel value, pixel value. Okay, this is the size of image, right? And then we have our B. This is B, structuring element. Very simple B structuring element. Dot dot. So when we perform dilation, so the dilation, the output of image from the dilation, this is the output of image of the dilation. Means that it's add with some pixel value from the original image A. So that is the operation of dilation. So we will see more example or more explanation. Okay, here. Dilation expands the connected sets of ones of a binary image. Binary image. Binary image, we have 0 and 1. So the function of dilation is expanding to make it a bigger object, something like that. If we have this shape, when we perform dilation, you get this output. Okay. When you have this, object that you fill, so filling the hole, gaps, and gulf. So we can use dilation. Instead dilation, it is adding a binary image, adding sets of logical 1 to the image. For example, if we have this object, so we want this output, so we perform dilation. If we have this object, we perform dilation to get this output. Okay, so that is the function of morphological dilation. Okay, this is the repeat back again. What is the structuring element from the previous slide? A structuring element is a shape mask used in the basic morphological operation. Can be any shape and size. So the same slide, the same as previous slide. So this is the dilation with structuring element. This is more. This is the example. Another example. I mean the detailed example by the pixel value. See how the dilation expanding the x. Originally we have only two x, two logical one. By using the structuring element of S, we get this expanding of original image X. So this is a dilation. Okay, so how it's expand? If you see it here carefully, this origin here, origin 1. So this is the origin. This is the starting point of the masking to this image. So this this is the one, start here and follow to here, follow next. If this one meet 0, do nothing. But if this one mask into 1 here, then add the structural element 1 and 1. That's why you get this expansion. Another one, then you add this one and 1 here, then you get another expansion. So this is how the dilation perform, right? So this is an example of dilation. So we have our image, and then we perform a dilation. then we get a good shape, good edge compared to the original image, and we move all the noises. Dilation with a discrete disk, the origin being inside of it, give an isotrope swelling or expansion of the image. Note that here the white pixels have been chosen as the object pixels. This implementation is based on the third definition of dilation. Black indicates the original pixel, and white the pixels that are added. In red are some place of the movement of BRX. So this is the point where the indicate the original pixels of, and white the pixels that were added in. So this is another example of dilation. Okay. Historically, certain computer programs were written using only 2 digits rather than 4. So this is the old text, or maybe it's not old, but there is a broken words here. So we can perform dilation, then you will get a clear. It's like you bold all the text. Bold means that you add some pixel to the original image. So this is the function of dilation. Okay, so this is the properties. Okay. Next is erosion. Erosion is opposite of dilation. So the erosion is shrink. Shrink. Shrink means that to make the original image smaller. Okay, so that we get a good shape of object. Erosion shrinks the connected sets of logical ones of a binary image. It can be used for shrinking shape, removing bridge. Right? For example, when you perform image analysis, you get this output, but this is the output where you want it as a 2 objects, but it has a connection here. So one way to remove it, that we can use morphological erosion. So we get the 2 output of circle object. So this is same thing. Want to remove branches or small protrusion, so we can use erosion. So this is the detail. It is shrink, shrink the image. So from here, perform structuring element, then you get the output. Originally, we have a few logical one, but when we perform erosion, then we get only a few logical one. Okay, so try to understand how this structuring element, or how the erosion and dilation perform into the X here, in order to get this output. So this is more example. When we perform erosion then dilation, we get certain output here. So it also can be used in many applications, like thumbprint, can be also used morphological. So next is opening and closing. So opening, closing is the compound operation dilation followed by erosion. So closing, we perform dilation first, then we followed by erosion. Opening, we perform erosion first and then followed by dilation. It has certain function for the image analysis. Some image you cannot just perform dilation, but you need to perform first dilation, then second erosion to get the output that we want. So we call it closing. Same goes to opening. So this is an example of opening and closing. Okay. So this is an example. We have the original image here. Perform dilation. Expand of the image. Closing. Erosion. We shrink the image. But when we perform closing, perform opening, we get this kind of output. Original image, opening, closing. So closing is better. Closing means that we perform erosion, we perform dilation. We perform dilation, we perform operation. Okay, so this is the another type of morphological. You can read by yourself, but I don't want to go details on this skeletonization boundary. Just read by yourself. So we can also perform grayscale morphology. Okay. So this is another example of opening and closing. Okay, I think that's all about morphological dilation and erosion. So you can check this slide as well also. Then try to answer this question in this.